Good afternoon, everyone. Welcome to our first online webinar for the Building Smart chapter, Building Smart UAE chapter this year. The topic of the webinar today is beyond the buzz, what AI really means for the AEC industry. All of us are under hearing about AI as engineers, digital lead, consultant, contractor, student, project manager, and all question coming around. Are we using AI yet? Are we failing behind? What we should do? Will AI replace the professional in the future? So there are many AI buzz around us, specifically about generative AI, and it has been presented as a changer. So even if we usually focus in our webinars about BIM and open BIM and standard, but AI is something that we cannot avoid, and we have to get ourselves ready. And the best things to get ready is to have clarification. What's AI? What is not? What it can do? How to prepare ourselves. So actually, the session today will try to cut through the hype and the focusing on practical reality. So just to know where AI can really delivering value for consultant and contractor, and if can we really see examples, if can really reduce the time, repetitive documentation, automation, etc. I'm honored to introduce our speaker for today, Dr. Ibrahim Fahdah, who is a leading voice in digital transformation within AEC sector and public sector in Emirat, with a strong academic foundation and extensive practical experience in BIM implementation and digital building permit system and innovation leadership in the region. He brings both a strategic perspective and hands-on expertise. His work sits precisely at the intersection of standard, data governance, emerging technology, innovation, and making him uniquely positioned to guide us through what AI truly means for our industry today. Before we begin, I would like also to encourage everyone who is attending to know that, as you know, Building Smart UAE is a collaborative community. If you are working with BIM, digital workflow, research, innovation, or doing case studies that could benefit the wider industry, we would be delighted to hear from you and to host you as a speaker in our future event. Please reach out to the chapter if you'd like to contribute, present, collaborate, or share your expertise in future session. With no further delay, it's my pleasure to hand over to Dr. Ibrahim. So, Dr. Ibrahim, the floor is yours.
Yes, thank you, Dr. Ali. Thank you very much for the introduction. I think you covered the main topic of today, so I'm not going to repeat what you just said on the aim or the goal of today of this presentation. And you already introduced me, so again, thank you, and I'll skip introducing myself for sake of time. Now, let's start with really looking at the big picture in terms of how we are affected as a human being in terms of technological disruptions. Over the history of our human history, we have seen, or the humans seen, different technological disruptions. I mean, the last one probably I lived through is the internet, and was the last big wave. But currently, we're seeing a new, arguably, it's a new technological disruption wave, the AI wave. So it's really impacting our life in all aspects, at home, at work, everywhere on the road, and it will continue to do so. So the focus of today is just try to put things in context, just for us as a professional in the AEC industry, how AI could affect us, or what use cases, application we could use AI for. Generally speaking, when I speak to people about AI, or you read on the internet, you get different views, different feelings about it, different opinions. Some are worried about privacy, security, ethics, job loss, and that's lead to some getting confused, concerned, scared, nervous, overwhelmed. There are other camp that are thinking about building better products, faster, safer, smarter, and those are excited, hopeful, and curious. So until now, we're really at the beginning of this wave. So it will take maybe a couple of years until really we could measure the real impacts and look back and say, yes, it was scary, was bad, or was good and it made things or life better. So there are some people, I mean, I'm sure you listen to those people online talking about how they see the future in terms of AI, like the godfather of AI, Jeffrey. He says, for example, this is a quote from him. He says, "No experience. We have no experience before of this kind of things. It was the first time a human being deal with such things." Similar quote from Elon Musk. He echoed that, saying, "Now we're seeing things that are smarter than the smartest human being." Sam talking about how agents, autonomous agent will replace a human being in the manual work or the things we do on a daily basis. Our job become like supervising those agents. You will talk about how AI is the first technology in our history that is able to make decisions and create really creative or new ideas. Whether you agree with this or not, that's a different subject, but there is agreement in the community, at least all those high profile people, that AI is affecting our life and it will continue to do so. This is why we see a huge investment, crazy numbers in investment in the AI. Now, for today, we're not going to talk about every aspect of AI. We will focus on the purpose of webinars. Our webinars today is in the scope of AEC. So I split the webinar into a few bullet points. First, we will just set the stage, talk about what AI and why it's different now. It's not new. AI has been 70 years in research and application. So why now? And then we move about talking specifically on use cases or application where AI really add value in our industry. There will be some demos. Most demos are open source, so you can, if you're curious to know more, you can always access those open source and try them yourself. We will end with now what? So, okay, we know about use cases and we know about AI. So what mindset we should adopt when we start dealing with AI as a professional? So first, let's set the stage, as I said, so we agree on what AI and why it's different now. Now, AI fundamentally is just a technology that's trying to mimic human intelligence in performing tasks. At the core of it, it learns from massive amount of data, more than any human being can read or deal with. And out of this data, it reaches or recognize or build, create complex patterns, and it uses these patterns to perform the task. The task could be predicting values, detecting object, classification, generate text, images, etc. All of this will be based on the pattern that it learned from, or the data learned from. Now, we see on or we hear on in the media that people talk about AI, and technically they more specifically talk about generative AI. But in a broad sense, AI is a concept. It's the broad concept, is the outer circle, if you want. But inside that circle, there are multiple layers. So as I said, the AI is the broad concept, but then we have the machine learning is the main way we achieve AI by training models on data. And then we have another layer or nested layer, which is the deep learning, which is a subset of machine learning that depends on what they call neural networks. It's a way of algorithm to create machine learning. And then we have what we have this buzz about all over the place, which is generative AI or large language model. Most of the media hype these days, they say AI, but really they mean, or they're talking about entirely on the generative AI or large language model. This is a slide very important just to see the big picture. Then when you say AI, it's not the same as large language model. It's the wider picture or the wider circle that encompass other types of machine learning. Now, I like this slide on on this slide, try to differentiate between what is traditional AI and what generative AI, and also highlight that the fact that AI is not something new. It started in 1970, and over the time, it found its way in real application. Typically, it's used for analysis and prediction, classifying, object detection. So we see AI, or we have seen it for many years, for the last 10, 20 decades, we have seen it as users. So when you have a spam email filtered out, or when you have your account blocked and the bank say, we suspected some suspicious activity, all of this is really AI-powered system. And we've seen also some application in the AEC, like object detection, hazard detection, all of this is AI. So it is really in the market, it is powerful, but the downside of that was it is limited to expert. So you need to be expert in the field to be able to use it. Now, what happened since 2017 when Google published the paper on transformer architecture, and then OpenAI, Sam and his team used this to create ChatGPT. That's where we start seeing this new kid in town, or generative AI, or large language model. And what's special about it? Two things. It can generate content, text, images, and code. And the other thing that is special about it is very accessible. We deal with it in a human-like interaction, and it deals with us or report back the output in a human-style language. And that's the cause of the buzz or the explosion of AI. So AI has been around, as I said, many years. Just generative AI, or large language model, happened to unlock its full potential by making AI more human, support human-like interaction, more conversational and accessible to everyone. So that's the key of the success of generative AI. Now, quickly, I will say that we see the world different from AI. We have perception. We see spatial, relationship, material, etc. So that's perception. AI doesn't think, doesn't sense. What happened underneath is that the input, AI takes input and convert this to numerical vectors. They call it embeddings. And then based on the pattern it learned from the model that it trained on in the lab, it predicts the next token. A token could be a word, or block of pixel, or piece of video, etc. So it's really not magic. Its foundation, generative AI or other AIs, is built on math. So it's a lot of mathematical operation happening in the back end. Eventually, as an end user, you just see human text or an image or a picture, but behind the scene, it's all mathematical operation. Now, generative AI doesn't come perfect. It comes with its own limitation. So one nature of generative AI is its probabilistic output, which means you may put a prompt, you get a result, you try the same prompt again, you get different result. And that's okay for probably drafting email, creating images, and so on. But it's not good for safety critical decision in many activity in our industry. So you cannot rely on structural analysis for a building and you say, okay, 50% okay this time, but then 80%. So we need black-white decision in many activity. In other words, deterministic output. So that's the first limitation. It might be a positive thing for some activity. Now, hallucination is another downside. Newer models are better handling this. It is when the model, you put a prompt and attempt to you a text that really very plausible, very seems factual, but it's wrong. But the way it's presented sounds like true. So that's another limitation in generative AI. The third one is the knowledge cutoff. What I mean by that, the model itself is trained on data, and the data at the time it trained is a snapshot in time. So it's not always up to date. So if you ask a question it's not trained on, it might give you a wrong answer. The other thing, it does only know about the data trained from. So if there is a special knowledge, let's say talking about the Dubai building code, assuming that the model didn't see it or didn't read it at all, if you ask about Dubai building code, it might give you wrong answer because it doesn't know about it. This is where we sometimes have this special customized model that trained on special data to give the correct answer, and there are two different techniques for this. I'm not going to go into the technical description or deep in depth, but there are two techniques. One called RAG, retrieval augmented generation, where you enhance the model with data, special database or knowledge base, and the other technique is called fine tuning, where we create a totally new model, or what they call modify the weights of the model, adjusting the pattern so it gives better answer. So those are limitations we keep in mind because it's not always perfect. But as I said, there's always workaround of those limitations and getting better and better. Now, quickly talking about models, there are hundreds of large language models on the market, really. Some of them are closed, like OpenAI, Gemini, and those commercial ones. And they are the open one that you can find them on GitHub, some small, some big. But the idea is there is different options when adopting AI for application inside a company to choose either open or closed models. Each has pluses and minuses. Like open source, you have control. You can take the model, put it on your server. It's perfect. So secure, private, no problem. But with closed model, you have stability, you have strong performance, probably better than open models, always a step ahead of open models. But again, there is a cost. You know, your data going to someone else's server, and security issue might be a problem for the company. So there is always trade-offs, and final decision will be based on some investigation, some evaluation to decide which way to go, open or closed. But my point is, it's not always open AI. You have to go with open AI. There are other free open source option. Now, that's the first part. We just try to set the stage, differentiate between AI as a concept and generative AI, large language model, as a subset of machine learning, a small part of machine learning. Now, we will dive deeper. Now we will move to the special part, talking about practical application of AI and generative AI, not just generative AI, in the field or in our industry, the construction industry, and trying to show where it really add values today. That might change in the future, but today, what use cases we can use AI for. So I tried to group them in two groups. First, the generative AI, pure generative AI, or large language model use cases. This kind of the accelerator role. It speed up doing things. Using large language model, for example, for language and communication, image, video generation, intelligent UI interactivity, and software development. This is big thing. So this is pure large language model. This doesn't borrow anything from old AI or traditional AI. Now we have the other bucket where we have use cases. It combine the power of AI, the traditional one, let's call it the traditional one, like computer vision, plus generative AI that sit on top of the computer vision AI to allow a seamless communication with the human being in a human language, natural language. So this is like combined AI types. Example of this: intelligent site inspection, intelligent robotics, predictive and detection classification task, where the machine do some task, report results in machine readable format, but then the generative AI take this output and convert it to a report, a summary, an image that a human can easily interpret. So those are the two camps or we can group or put any AI application in the industry under either category. Now, I'm going through those application one by one and trying to show some demos along the way. So the first one is the language and communication. Technically, I think already all people these days using AI, large language model for language, whether it's searching or summarizing or drafting text, all of this happening. One powerful thing about generative AI is the semantic search. In the old days, if you want to search for some text in your documents, you put keywords, and it used to be match one-to-one. So if the word not found in the text, you don't get anything. But with the semantic search, generative AI have the ability to capture the meaning, what you're trying to find. And it might not return exactly the same word, it might get you the closest words or the text that really what you're looking for. So that's called semantic search. It's beyond keywords. And that's so powerful features. Summarization, when you have large document and you want just to get a summary for a meeting or whatever, then you can quickly get the summary. So as the first demo, so we will demo the language part or the use case using the Ask Dubai building code. And Ask building Dubai code, what happened during the development, I was developed is we have the document, the Dubai building code, which is a PDF file. And this PDF file is given to large language model. And out of that, it created its embedding or the indexing in a way. And then user can interact with this agent or this chatbot to get semantic search, do some semantic search inside the Dubai building code. Now, I think I have the link, so if we can show it in action, probably quickly. So you can go to it through the link, visiting Dubai, building Dubai, build in Dubai website, and you will be presented with this interface. It's just a simple interface. You can put your question here and hit enter. What happened now, the prompt itself will be sent to this special chatbot that only search within the Dubai building code. It does not look at any other data set or knowledge base, etc. This is why the answer you get back is very accurate, very correct, because it's searching in the right knowledge base. Now, hopefully, it will get something. Yes, we got now the output. And eventually it will list you the answer, and not only the answer, it will give you the page in the document or the code if you are after getting more details. Now, at the time this happened was state of art, but easily now anyone has knowledge base, custom knowledge base in your company or your hard drive. You can easily upload this to ChatGPT or custom ChatGPT and create your own custom search engine, semantic search engine. So that's the first demo on the language. Now, talking about language and communication, we saw the first case, and that has a broad application in AEC. We have a lot of documentation, and sometimes we struggle with this large amount of documents to search in. So if a company have requirements to do semantic search, they can easily create their chatbot agent. The second application is instant image rendering, and this is also amazing happening here. A lot of architects feeling bad about this, because now you can create images from text. You can easily put a text and you get an image. You can put a base image and ask the AI or generative AI in a prompt, text prompt, to adjust or render the image in the way you like. And almost it's free to do this these days using Nano Banana or other tools. So this is a powerful thing if you are trying to create design concepts. and try to explore different design options to discuss internally or with the client, etc. So this is powerful for architects. Now, as a demo, I will just show a video about how this integrated into Revit. I have this on LinkedIn. The source code is, and the whole thing that I will present now exists on a website. Everyone can access it and integrate this tool inside Revit. But basically, so in Revit, you can add just a plugin. Let me see if I can switch the sound. Okay. In Revit, you can have this plugin that take screenshots of the back end, and then you add to the text box here the prompt, and from the prompt and the text, the base image, this will be sent to the Gemini large language model, and the model itself will return the rendered image. Now, nothing has to do with Revit. The same plugin or the same code can be integrated with any software. I just happen here to demo it in Revit. So again, in the back end, the plugin take a screenshots and send the prompt to Gemini, Nano Banana, and return the image. Of course, you may say, I can't do this manually. I just take it screenshots manually and stick it in Nano Banana, and that's correct. But you lose the convenience that have this integrated within the software, the same software. So that's on integrating rendering into our BIM authoring tools or BIM tools. Now, rendering used in Tech in Revit a lot of time and resources on your machine, but now it's so quickly. So the next evolution, or the third application of generative AI, is moving from static images to generate videos. And again, this is a very powerful concept for architects, because now you can generate, or you have static images you are generated themselves yourself based on taking them maybe by camera or whatever, or maybe use the generative AI to generate these images, and then from these images you can take them and convert them into a presentation, a video, more than just not static images, but video. And doing this, it used to take like weeks of work from architect, and you need special people with the skills, technical skills, to be able to do this. But now easily a kid can do this with images. You just need to learn basic prompts and use the right tool, and you can easily stitch them into a video that easy or nice to present in a meeting or to the client, to show, again, to show the different design for a building. Some people say this is always have some glitches or not perfect. I agree with that. But when we talk about images and videos, we don't mind, I guess, for brainstorming or for sharing ideas, to have a slightly imperfect images or videos. That would be fine in broad terms. Now, I think I could sum up the image and vision video generation by saying that we're really witnessing a paradigm shift in visualization in our domain in AEC. So it used to be you have to do things manually, but now you do it by interacting with AI through a prompting. So you don't need to do things manual. We're moving from doing static images to easily create those images or convert these images to video. And the job used to require technical people who spend years knowing all this rendering and Photoshop stuff, but now is prompt skills, how to create the right prompt or give the large language model the right prompt. It used to cost a lot of money because buying license, hire those people. Now it's fraction of that cost. And I guess above all is the time. It used to take lots of time to do the rendering, create those images and videos. But now, instead of weeks, it may take just hours to complete the job. And it's very professional and very ready to production or presentation. So we talked about language, communication, application, or use case. Then we moved to talk about images and videos, visualization. Now moving to the fourth use case or application is intelligent user interface interactivity. What I mean by that, typically, when you work with software currently or traditionally, we use the mouse and the keyboard to click on the command and the task that we need to execute using the mouse and the keyboard. But things is changing. Now you can drive software using just prompting. Prompting, it could be a voice prompt or text prompt. And that reduced the amount of time for non-technical people to learn about software. So you just need to prompt, and then the AI will take the prompt and understand your intention, what trying to achieve, and convert that prompt to a command, send it to the software to execute. So you don't need to know about where is the command, which menu I should visit, which button I should visit. So that's a very powerful thing for non-technical user or people don't know the software. The other thing's productivity, because now you can do repetitive tasks easily by copying the same prompt again to repeat the same. If you have a repetitive task, you just copy those prompts and to execute the command. Even better now, like Claude or other client, OpenAI client, you can give it what they call it skill. So skill is a set of instructions. So you can embed all the tasks you want in set of instruction or workflow, and then execute that in one go. So that's very powerful things. The flexibility, this is a big thing because now you don't need UI, more fixed UI, fixed dialogue, fixed menu, fixed button. All you need is just set of tools sitting on a side, ready to be executed by the AI based on your command or your prompt. So there is a flexibility, huge flexibility by reducing the amount of user interface dialog boxes in software. Potentially in the future, we will see this happening. There is a demo on this, how I integrated the Claude with Revit. I just show the video here again. So this is where we have Claude, part of Revit. You just set it, put it aside. And now then you can integrate with Revit through prompt. So like here, there is a command say hide the walls in the active views. Now the AI will know which tool to call to execute the command. And as you see, it picking up the right tools and telling you what tools is being called. Another example would be, let's see, it's restoring the views. So again, if you want to interact with the view, you can always set the command or send the command. So what we're using here, we're using what we call it MCP, Model Context Protocol, which allows software to interact with the AI or allow the AI to interact with the software and send or execute the right command. So as you see in this example, there is no manual interaction. There is no manual interaction with the software itself. There's no clicking on the mouse, on the menus, on the command. It's all done by interacting with the AI, and the AI does the job. So that's what I called intelligent, or we call it intelligent UI interactivity. Now moving on to AI coding assistant, and this is about software development. I think I didn't expect that AI will be so fast. AI coding assistant will be so fast doing good jobs in software developments. It's really improving rapidly, these things. So AI coding assistant already really changing how software is written, whether it's AEC in our industry or any other software. I would say there's no software now, the software developer without AI coding assistant on their system, and unless they are living on a different planet. But that's both exciting and terrifying at the same time, because the AI assistant, coding assistant, can generate a lot of code in a very short time, very complex code. So the review process is very tedious, and a lot of developers skip this check. So that's very scary or worrying for production. But for prototyping or dirty work or locally, just prototyping idea, working with concept, it's a perfect tool. Another point about AI coding assistant, everyone now is software developers online on LinkedIn. A year, 2 years ago, I know some people did never talk about writing code. Now everyone posting on LinkedIn on POC they created, and how awesome is that? That means AI coding assistant lowered really the bar for entering the software development domain. Moving on to application 6, everything I talked about before, it's pure generative AI. We didn't touch on application using traditional AI. Now we're moving to the combined or the hybrid system, hybrid AI system. Not only generative AI, but using traditional AI to make powerful system. As an example, intelligent inspection. So as I said, we have inspection or AI computer vision used in inspection before generative AI, but generative AI gave this an extra boost, because now from the images the drone, CCTV camera taken, it used to be processed by the pure, let's say, vision model. There is no large language model, and the result used to be machine readable text or data. Human could not easily read this and get the meaning of the output. Needed some processing. But now putting generative AI on top of the existing visual models, we could turn those results to human readable reports or text, and that give the feeling that you interact with intelligent inspection tools. So that's again gave boost to the traditional AI, powering it by using generative AI. So I think I should really mention here that for intelligent inspection or vision models to work perfectly, there need to be a specialized fine-tuned vision models. It's a must requirement for accuracy. We cannot just use any large language model or vision model to get the accuracy we are seeking. It has to be properly trained on special data to get the accuracy needed. I will show 2 demos now in a minute, but as an example, we can use the intelligent inspection to do 2 types of tasks. We can group all of these tasks we talk about in vision models into 2 categories. One about object detection and recognition, and the other part or the other category is image classification. Like, for example, if we have a crack, if you have a wall, classifying the crack, whether it is worrying or risky or need the treatment or not. So this is kind of the 2 application for using vision model as part of the inspection, intelligent inspection. So there will be three demos now on this. First is using vision model, no generative AI or large language model. The demo I'll show in a minute. It's just traditional old vision model being used for crack segmentation. And the other one I will show a plan parcel. Again, this demo do object detection in the drawings, in the plan. But again, it's just a pure AI, no generative large language model. There will be another one, again, on floor plan, detecting walls and room in a drawings. Again, pure vision model, no generative AI. Well, the reason why I'm putting these three demos is just to show you that AI was powerful before generative AI. We didn't need generative AI to use it. It was already capable of doing many tasks. It just happened generative AI took the credit for a lot of things. If you allow me to show the first one. So this example is open source. I downloaded the source from GitHub. It's written in Python, but I did some processing, convert the model to be able to run it on locally on my Windows. So basically what you need to do is you have trained the model. The model already exists on my machine. It's about 200 megabyte. It's already trained. I didn't do the training myself. I just took the output, which is the model, and converted to some format run locally. So all you have to do to use the model to use just select an image of a wall with a crack and then run the segmentation. And automatically it tries to extract or segment the cracks from the wall and drew different representation. This is like the whole thickness of it, and this is like the center line of the crack. So I'm just trying two different examples so you see what I mean. So there is a crack here again. So this is a perfect example in our industry for inspection tasks. If you have a lot of images, you can easily train a model on this data and then produce a vision model that is capable of analyzing the images, whether classification or detection. So that's the first example on using vision model. Using the second example, which is about floor plan element detection. So I will take an image. Again, this is a similar thing. There is a vision model behind this, open source. I'm loading a plan here. I'm say detecting the rooms and the wall in this plan. Sorry, detecting object in this plan. So this example, detecting objects inside the plan. Of course, it's a trend on what to detect, and this is why it returned certain types of objects. So it's telling me here there is a 12 chairs, a double bedroom, single bedroom, etc. So and highlight them or mark them on the drawing. So again, this is an example of open source. It's already exists on GitHub. It's written Python. I just again got the model, turned it to something I run on Windows, and it worked. I will show you how this ran in the cloud because I got this from someone posted this on LinkedIn. Sorry, let's just avoid that. So this is the main source. So they have deployed this online. So if you click on an image, it's exactly the same model. It just happened here. I run it in the cloud. So it gives you the same output. So this is an example of parsing a floor plan to identify or detect objects. The third example on the category of vision model is detecting walls and room boundary. So again, this is open source. I just happened took the model, converted to local to run it locally. So I'm taking here a plan. So this is a plan, right? So I click on the run detection. It's trained on detecting walls and room only. So as you see here, it's selecting the room in blue and walls in red. I can increase, decrease the confidence because there's a factor. So how confident this is a room, how confident is this is a wall. So if I put it 0, it gives me everything. If I need to increase the confidence, so make sure that I'm getting exactly rooms and walls. Of course, you get in this case less number. There are 3 models the researcher experimented with, because this was academic research. If I select another model, it gives me slightly different result. So this is where the investigation phase to build the right model for the job. So that's the example on, these are the example on using vision model. There is one example that is vision model using large
Dr.
language
Ibrahim,
model. Yes.
there's a question like how accurate is this model? Because I think this is very interesting use case. This object detection and reading the floor
how
plan.
accurate this is will be evaluation phase, Dr. Ali. I did not do evaluation, of course, but from a human or for quick evaluation, it did good on certain images, less on other images. But this is where we talk about accuracy. If the more you train it on data, on real data, the better accuracy you get. So rubbish in, rubbish out. That's the rule. Always in the AI domain, whenever you train a model, there is a phase called validation and testing to ensure a certain level of accuracy. This is where you need some people to build the AI model for you.
But in theory, I mean, if we increase the size of the training data set, if we do a kind of verification improvement, so in theory, the accuracy should be improved with time, right?
There is the number of data and the mix of data or the variety of data. How it's not only because you could have a million image of the same type of the same floor. That doesn't make the model better. So it has to be the quality of data, different type of floor plans. If we talk about floor plans, just to make sure that the model is trained on different types, different scenario, different layouts, and that will ensure quality. But what I'm trying to say here, it's not rocket science. Give me the data, give me the images, I give you a model, and we are there. We do first iteration. Then if it's not okay, we train it more on data, or we try to fine tune it until it really works as we wish. Just carrying on now, the new large language model, many large language model now, like OpenAI, have vision capability built in. And there is an open source, one example. I tried it locally, but if I try it now on my machine here, it will kill the machine, because typical vision model are small in size, maybe 100, 200 megabyte. But when we talk about visual large language model, they are not just visual model, they have large language capability, which I mean, doing the typical task we talked about earlier, like reporting, communication, drafting, summarizing. But they have on top of that vision capability, but those are like 10, 20 gigabyte, and they need GPU to run. But they are powerful. If you fine tune them, you get the best of all. You get large language model plus vision model, then you are ready to go, and everything will be easy right after that. So moving on to the number 7 application, intelligent robotics. And basically this is just putting the vision model, the brain, the vision, the eyes on top of hardware machine, and then putting this in the physical world. Could be a drone, could be a robotic scanning. So it's just combining the two components together. You can do tasks like scanning, checking if the building is as built, reporting progress automatically, creating reports automatically, because the images will be analyzed by the vision model. The LLM will take those results as a machine readable and convert them to human reports, easy to write by human. So that's the extension application of intelligent inspection. I think already covered this, saying you cannot get AI, good AI output unless you have a good AI models. And to get AI models, you need to have spent time in training, and training the model require many tools, many specialists. It may take time to collect the right data, clean the data, because there is sometimes you need to clean the data, sort the data, etc. But once you have the model, the right model, everything after that, it can be an extension, putting the user interface, putting the database, etc. Everything becomes traditional software development once you have the AI model created. So it is the secret sauce. Now, I guess by now I feel I covered the essence of the presentation today, which is the use cases. I only need to say that it doesn't matter how much you see application online, always you can group that application or the example you see under certain categories. Could be language, image, videos, or as I showed you, the computer vision or vision capabilities. So you can always put it under one of those categories. It doesn't matter what application you see. Now, moving just to wrap up the whole thing is just quickly. Now we know what AI, we know the application. So what next? What mindset we should adopt or go about when we look adopting AI in real application in our domain? There are two approaches. We see them both. Both could be valid depending on where you're going or what you're trying to do. So you could go fast and the furious approach, and this is okay if you just after, let's say, rendering videos, images, etc., dirty or BOC software development, because it doesn't matter what happened there. It's not disaster. There's risk, very small risk in that. It's just a small issue. If you have an image with an extra finger of a human being has an extra finger, it's not an end of the day, end of the world. A bug in a software is just inconvenience. But on the other hand, if we're dealing with sensitive safety issues, we cannot just adopt any technology. We have to be careful how much we progress or adopt the AI. So in this case, we have to or must adopt a verification first approach if we're dealing with safety critical tasks. In terms of strategy, technology should be at the bottom of the whole thing. So a lot of people think AI mean I need software, I need quite tools to be able to have AI capabilities. I think technology come at the bottom in terms of asking a question, what technology we should do. The first question should be asked is what the purpose, why we doing this? If you have a problem, you're trying to solve it, the question is, do I need AI? Maybe I don't need AI for the problem. Maybe I can just simply solve it in traditional programming. So you need to know the purpose first. Second, you need to know if we have the right people, the right skill, the right mindset. And then talking about processes, do we have to change anything in the processes, the workflow? Because bringing AI doesn't solve things magically. The workflow internally, the business logic should be fit to adopt AI. Talking about data, we talked about training. Do we have the right data to train the model if we're going to build our own model? Do we have the data in the right format? Because AI, like human being, they like the text to be in a certain format. So it's like it, for example, AI enjoy having JSON data more than maybe PDF file. So do we have the data in the right format to feed it to the AI? And then the last question could be asked is what technology? Should we buy everything at the beginning, or should we take it slowly, maybe try different tools, BOCs, prototyping, and increase the adoption of technology gradually as needed? This should be customized based on the application. So I cannot give one single recommendation here. I'm trying to say technology is one component out of many other components. Now, that's the webinar for today. I hope it's covered the purpose of it or the aim from it. Now, just some quick takeaway from the webinar. Just I want you to know that AI is broader than generative AI. A large language model happen to give the source, the magic ingredients or the secret sauce, which is allowing a human being to interact with AI in a very universal human way. It's amazing in that. The second one, AI application is very vast. Don't get confused. Don't get like lost in the jungle of all these application. At the end of the day, all those applications can be numbered or come under a small number of categories. AI eventually will find its way in our industry. The adoption will be slow than other industry due to the nature of our industry, because for example we have these safety critical checks, so we cannot easily just adopt any output. We have to be careful how we go about it. I think also normally AEC industry is quite slow in adopting technology, but eventually it will find its way one way or another in certain applications. Now, last but not least, AI is arguably the sixth major wave of technological disruption. It's here to stay. I think only time will reveal how much it will impact our life, positive or negative. That's remain to be seen really in the future, but certainly it's here to remain and it will affect every one of us. That's all from me. Maybe some of you may have question. You can always reach to me if you want on LinkedIn. If you have a specific question, technical question, by all means, if we cannot cover any of that today, please always reach on LinkedIn for more discussion if needed. Thank you very much. Dr. Ali, over back to you.
Thank you very much, Dr. Ibrahim, for this valuable insight. For me, it was a really interesting discussion, and I think there are many things which are clear after this webinar. I hope for most of us that AI is not a magic. It is magic, but not the magic if you understand the basics and how it works. And also, AI is here to stay, but not to replace us or to replace professionals, but to support them, to enhance their workflows and to automate a lot of tasks and add value. Again, when we come back to the BIM, building information modeling, or open BIM, interoperability, structured data, all of these are related, I believe, to the AI, because at the end, without structured BIM data, without really defined the processes, AI become noise more than value. So rubbish in, rubbish out, as you said it yourself. So again, I would like to thank you, and also to say that the Building Smart chapter exists actually and managed by Dubai Municipality to share knowledge and to elevate best practices to strengthen our industry together. So if you would like to be present case studies, collaborate with us, contribute to any further discussion or event, we would be very delighted to hear from you. So we look forward to continue these important conversations in further webinar to talk more about AI and other applications. And I hope to seeing you at our next Building UAE event soon. The webinar will be recorded and will be uploaded to the Building Smart YouTube channel. Please use the link I shared at the beginning of the webinar if you would like to register your interest to join us as individuals or company, or at least to be ensured that you will be invited to the future event. So with this, I say have a nice day ahead, and thank you all for attending. Thank you.
Thank you.